Oh yeah, in this vid I show this ball and oval turning attachment that I made from a lathe for the cross slide, and I show it in use as well to make new oval handles from a mill to replace these crap plastic or Bakelite phenolic type things. So got a bit more beef. So yeah, this is what this video is about. The way I set it is there's no science behind the method. I just bring the arm out to where I think I need it, get approximately in the middle, and I'll just measure with a scale, see what the distance is between the tip and the workpiece, and I'll just measure at the side to make sure that I'm not going to get down to the actual bar before I clear the middle. In this case, I didn't set it far enough away originally, so I measured it, realised I didn't have it set right, so just moved the bar out a little bit more. So that is approximately, it doesn't bend enough. Get some gauge blocks or something, or a little angled adjustable parallel or drill bit or anything, but I estimate that about 9mm from the tip to the part. So I just measure at the side, and 9mm is easily going to clear. It's about 14. So anyway, that's the distance. Then it's just the carriage movement left to right. So I just swing it. I'll just move the cross slide in and out to get it so the tip is just barely touching the edge. I'll just swing round to the other side. That's too far away. So I'll just knock the carriage a little bit. It's just a bit of experimentation, that's all. So it just touches. And I measure how far away the tip is from the work. I'll just split the difference. So I just tap it the other way. Move the carriage in. Cross slide in, sorry. It's just touching the end and yeah, touching the end. So I'll just mess about like that. Carriage in. Cross slide in, sorry. You know me messing my words up. Right, that's just touching. That's just touching. So I know now that that is in the centre. Easy as that. Right, on with it. So I just move it by hand. Everyone tends to use a bar, but if you use a bar attached to the actual jig, you're swinging it round, the tailstock gets in the way. You need to test I need one anyway. I need a tailstock for this protrusion from the chuck, and also it's only a 1/2 inch bar, so there is quite a bit of deflection if I don't use it. I am to attempt it without the tailstock, to be honest. So I'll just turn it on. I'll just spin it by hand. Move it in about 3/4 of a mil. Now when you come off the edge, it does tend to want to jump. So I've got my finger underneath here on the dovetail. You'll see it anyway when I do the strip down. I don't hold my finger there, obviously, I just hold my finger underneath. Just move it in 3/4. Another 3/4. I'll just keep on doing that. These chips do get quite hot though on your fingers. When the bar starts to heat up, these start to heat up. So I'll come back to you when I've got a little bit deeper. These chips are starting to get straw now. They're a bit hot on the fingers. Got about 3mm to go. Ease off the pressure a little bit when you're coming towards the end of the cut, otherwise that starts to fly. Fine with this setup, it's a lot smoother to work that way. Working this way, it starts to chatter on this end if it's further away from the chop. Right, I've got about, just check the calipers, I've got about 0.7 of a mil to go. So that's 0.35 on the indicator. So I'll just move that in 35. This will be the finishing cut. I'll speed it up a little bit actually, because it's the finishing cut. Because there's a little bit of a flex, you saw me on previous cuts moving this back while it was still rotating, and it was leaving marks on the work because there is a little bit of flex when it's not under load. When it's under load it stays pretty much stable, though it's not under load anymore, flexes up a little bit, changes the position, and then that's why it leaves a mark. It raises up a little bit, so it's still cutting the radius. The lower it drops, the wider the radius is going to be. When it raises back up towards centre, it pinches a little bit, if that makes any sense whatsoever. And that's why it leaves marks. So that's why I left it where it was while I measure. Looks like I went over. I was shooting for 41 and I got 40.8 at 0.2mm under. That's a metric mile mark. And then with this back, with carriage back, I'll just deburr it a little bit with a blaze file. Scotch-Brite. Bit of GT85. Smoking a little bit. Always make sure you deburr before Scotch-Briting. You don't want to get to the edge and it grabs hold of the Scotch-Brite and turns it into, you know what I mean, just starts. You don't want anything snagging while you're holding it. Paper towel, not so bad, but Scotch-Brite, rags, anything like that, you don't want snagging. That is damn hot. Where's that? That's job done. Now, unfortunately, because I've had to use a live centre, I've now got a centre hole in the end. That's all I do now. Get the spanner. Wherever my spanner's gone. Where the hell is you gone? Oh, this workshop is a fucking joke. What I'm doing is I'm tapping it an 8. I'm going to make some little brass caps. Oh my god! I tell you, if you could see the other side of my workshop, you'd see why I can't find anything. That disorganised, it's all real. Right. We'll engage the what's it? Full gear. Engage the ball gear so it's so the spindle doesn't spin while I'm tapping. You get the gist. You just follow the tapping. You tap the hole. There we have 3 fancy handles for the Myford VMC, which replaces, you can see the mess in this workshop, I can't find anything, replaces these. Needs to be far enough away to focus. Replaces these phenolic or plastic phenolic caps, which are a little bit boring and generic, so I thought I'd use the attachment that I made to make new handles for the Myford. Right, here's the construction of the jig. There's the base. Now originally I only had aluminium, I didn't have a piece of steel big enough, well, the right size for what I wanted anyway. That was chucked up in a 4-jaw chuck to turn the thickness down for a register in the middle. That's threaded M10-1. The reason why I chose M10-1, M12-1 sorry, is because it's a wide, strong diameter, but the length of the thread isn't that long, because I had to put a recess in the back as well for a lock nut. This part was a lot thicker. There was something that I posted on Facebook about putting that in an old slimline 4-jaw chuck on a horizontal bandsaw to lop off the excess rather than turn it all to swarf. But I turned a board down less distance than the bottom of this. There is a gap there. I used a feeler gauge. There's a very slight gap there. It's something like 0.2 of a millimetre, if I remember right. There's a gap there, so basically it's that surface and that surface that mates. Not going to do it at the moment because I'm using a Sony. I'm using my main camera, a Sony A7, to record this. Okay, my hands are dirty, but it's not molly grease dirty. I don't really want to get molly grease all over the camera, definitely not on the lens. So I'll take this apart again after to put the grease in. You might, the video of me turning that handle for the mill was done before I took this apart, so you can see even without grease and proper tuning, like tighten it down to the right tension and everything what you want, it still turns pretty damn good. That was pretty loose as well, it wasn't tight. When I went to take this apart I didn't even need a spanner. I mean, to undo that nut, it just came away with my hand. So with me turning this round, even though it's got these thrust bearings, it's still loosened itself a little bit, but it's still, that's probably why it's got that little bit of flex in it, where I could do the cut and then when it's not under load it springs back up again a little bit, and then when you turn it back round to the start it leaves lines on the mark, lines on the work. Can't talk this morning. This, instead of turning the hex down, I just used an M12 bolt, just locked it off and then just threaded it M12-1. I stuck it in the chuck just to turn the 8.8 off it because I can't stand seeing stamps on stuff that I'm using. Obviously fixings to bolt stuff down, obviously I don't mind, but I'll just put the bearings in first, don't it? These are about 26mm diameter and they'll slot in like that. Then goes the bolt. And that tightens down. We're supposed to tighten down, that's it. making sure you grease the mating surfaces and the bearings. This needs a little bit of speeding up, I can see. So the problem when you do a fine pitch thread, it takes a lot more turning. Should have made that recess wider. Even without grease, that's still pretty damn smooth. And then so you'll get the tension that you want, and then you put the other nut on the back, and because that's the thread in there and then you thread in this, it's like ringing two knots together, just tightens down on the thread. Locks the thread. Right, these set screws, I've turned the thread off the end of them, just that little bit for ease, because when you put them in, you don't need the thread. You know what I mean? You've got these recesses on the back of the gib strip that you make. You don't need the thread for that, it's just for pushing. It's a lot easier as well. Let me put one in. Let me put one in for now, because this is going to be taken apart again. Should have put it in the middle really. That holds it in place, so when you're pulling the slide forward and backwards, this doesn't come out with the slide. Put that in. Now these holes are M8, standard M8. I've drilled down as far as I can go without the holes protruding out the bottom, because these two here are level with the dovetails, or that one in particular, because that's the gib side. So that, if it had gone all the way through, it would have been coming through where the gib strip is. So careful when you drill those that you don't go all the way through, and also if they go all the way through, you'll just get a swarf going in between the slide and here. So it's pointless going all the way through as well. It's more machining. I do need to make another jig for this, for setting the ball, setting the centre. What I plan on doing is sticking this on the mill, indicating this so this is perfectly centred with the spindle, and just drilling a little centre hole in the top of the bolt head, and then that way I can use a jig like, I'll get a piece, just a second. Right, that jig, what I'm planning on is getting a bit of square bar with that centre hole anyway, with that centre hole in there. Getting a bit of square bar with a hole in it, get a piece of round, mill half the diameter away, so you've got a flat there. Get that to a point, and you just put that through, and then a set screw in from the side. So the idea is that was you'll centre this bar, get this in the centre there, and that sticks up, and that flat you rotate it so the flat section at the top of the rod touches the front of the bar, the faced off bar that's sticking out your chuck, and then that way you know that you've got that centred on the you've got the whole bar, whole jig centred right on the end of the bar. and then you can set the distance that you want the tool to rotate to make that ball, and then you move the carriage across a set distance, and then when you make the arc you make the ball. But that's what I need to make, because with that over the top, that's the only problem with this design. That over the top, you can't get it centred very easily for turning balls. Without what I turn for the handles, you don't really need it. I've showed you anyway how I've got it centred. You don't need it that accurately set before you start. You just line it up before you start turning. So I'll tighten that up just loosely. That's eccentric turning. Bit of an obvious thing to say that was, wasn't it? You're not going to be able to turn that any other way than eccentric. How I did that, imagine another section of steel sticking out the back, it's just a stub. I turned that was 50, that's a 50mm diameter bar. I turned a 30mm stub on it, turned it down by 30mm for about 30mm length. Stuck that in a collet chuck, and did this. I used the collet chuck to turn the handles, so it's off now. I only just did this temporarily. To offset a round bar in a 4-jaw chuck, you can see these are the outside jaws at the moment because I've got the plate in, but with a 50mm diameter bar, unless you want it just gripping just that little bit for the eccentric turning, which I don't think you want to do, you want to use the whole length. So you'll be turning the jaws the other way. To offset that bar by 10mm, it's off the actual front of the jaws, so 2 of the jaws will be gripping at the side. Not only that, when you want to adjust the distance of the offset, you're adjusting all 4 jaws. Every single movement you're adjusting all 4 jaws, not just 2. Because you move it across, obviously these will need to move in as well because they're gripping at the sides. So I decided to get the squared plate, hold that in the 4-jaw, bolt the collet chuck to it with a 30mm ER40 collet, and then that way you just centre it up first, so 2 jaws are then set, and all you've got to do then is just move the 2 jaws to get the offset that you want. Tighten them all down, turn it, and obviously Bob's your uncle. So that's how I did that. Eccentric turn that way, then took it off, put it in a collet block, that end in a collet block, put it in the horizontal bandsaw, chopped off the stub that I don't need anymore, stuck that on my other lathe with another collet chuck in it, and then just faced off the bottom, and that's how I turned that part. So get it back on the tripod. The tool shank has got a slot in it. The hole on the top of that is just shy of 14mm, and then the hole all the way through is 8.5. This is a bolt that I made up. The idea is the bolt fits through there because it's shouldered. It's a shouldered bolt, so it presses down on that. Now I do need to make a curved washer, because when you turn that, there is wear. I've only done it a few times, so there is wear on the bottom of the shoulder. As you tighten that down, the edge of this on both sides is grinding that away. So for longevity, it's better to have a washer in there. That'll fit through. And another thing that I need to do, I need to make another bolt. with a hex head on it, because the amount of strain that this takes, it's not tight enough to do it down hand tight. You've got to be able to get a spanner on it and tighten it down a lot more. That's what all those marks are. There's a few marks on that nail, don't know if you can see it, because it was moving on me. So I got a pair of pipe grips and I just tightened it down a lot tighter. Now it doesn't matter to a certain degree how much you have that off centre. It doesn't have to be perfectly on centre all the time. You can turn it like that if you want to, because the whole jig is moving on that one centre. If you have it right out here, that's another thing. But yeah, it doesn't matter. It doesn't have to be perfectly on centre. That can be across the side. And turn like that. And like I say, it doesn't have to be perfectly on centre. So that when you've got the work here and you've got a spinning chock, you've got the stub of you've got the main part of the steel that's sticking out the jaws of the chock, or the collet chock, and you've got the recess, and then you want to turn the ball. You'd have it set off to the side a little bit at an angle so you can get more round behind the ball before this touches the chock. Or the other way around, the tail stock, so you could have it on the other side. I've drilled these two holes here for while it was in the jaws. I thought, while it was in the mill, I thought I might as well put those there for another jig, or for another use, rather than just have this as a one-trick pony, just a ball and oval turning attachment. I don't know, I might want to stick like a fluting, like a little spindle, motorised spindle, with a router bit in it, or a end mill, and cut flutes, index the spindle round and cut flutes on the end of a ball or oval, who knows. So that's a bit of a naughty. I forgot to mention the crater that I got this idea from. I was thinking for a while how to bolt a tool to the workpiece. And he's got a post, and he had that idea of having that slot and the bolt through it, so it's like a dual acting. As you bolt that down, bolts the post and the tool in one action. So that was his idea. That was Dr. Doktor Phinn. I'll put a link to his channel in the description. Everything else I designed myself, and after I designed it and started making it, I saw another video with something very similar, a bit of a thinner bar. It didn't have, if I remember right, it didn't have the mating surface underneath it that contacted with the top. It ran on the actual bottom. That's where the pressure was put, and it was a thinner bar. Instead of it coming up and across and up, it just came at an angle, the dovetail angle, and then straight up. So I didn't rip that off anyone else. It's just this idea. This was a straight, Dr. Phinn's was a straight post. And I thought, how do I do this so it looks a bit flash? Another thing, a small thing. This is a dovetail cutter that I made about 2 or 3 years ago. I decided to use it, and so because I've got a bit more experience now with clearance angles, it was tearing up the dovetails a little bit. I'm just taking this off. Just take this off. And also the radius was way too wide. It's alright for roughing, if you can see that. I had to get it back on the mill and index it. But this at the top there is, actually, just zoom in rather than get it closer. That's as far as it will zoom. Isn't autofocus properly, but hopefully you can see it. This corner here is a lot sharper than this corner, and the same on that side. Now when I was putting this together, I put the give in what I made. I'll show you the jig that I've made up as well for doing the gib. When I put the gib in and tightened it up, the dovetail wasn't actually touching on this edge. The reason why is because that was too curved on the base, and that was too curved on here. So I needed to get that in the mill and make it sharper. And with that sharper, I put it back in, and that is actually touching now. I didn't have to do the same with this, thankfully, to get that all bolted down and indicate that in properly. The reason why is because the inserts that I used were TNMG or something like that, is it? So there's no relief. I normally have like that 7-degree relief for turning, so there's a lathe tool. You'd have a relief angle underneath. There isn't on these, so you can use those inserts both sides. I noticed when I've been turning that this is a different insert. I've just put this in now to show you, but there's a hell of a lot of rubbing around that side. So I took those out, put these inserts in. I thought, well, these aren't going to last. It's much more of a fine point, and it's got a relief. And these actually did a damn good job. That's the same edge that I used for both sides. The dovetails on both sides, and it's still perfect. So it's still worth, in a way, using these for roughing, and then when you're doing your final passes, use these. Now, another thing what I was thinking about, it's all right with that design insert. It's all right doing the bottom of a dovetail like that. Zoom back out. Like that, because what you can do is you can think in advance and just mill this centre section down a little bit more, or end your dovetail a little bit higher. So the bottom of these bottom edge of this cutter isn't rubbing as it's turning, it's rubbing that surface all the time that you've just cut, and you're going a little bit further, and it's rubbing again, it's rubbing again, it's rubbing again. Now if that was lower, that wouldn't be an issue, that's easy to do, but with this side it's a lot harder. I've got to clean that up still. You see how that's rough, there are a few chatter marks on that surface, and that's a mating surface. When that's bolted down, I mean, that is literally, you'd set it and then tighten it. It's not like a lathe slide where that's going to be sliding all the time, but I still want to clean that up. But that's the actual mating surface there, so you want that to be clean. So I was thinking, instead of using these triangular ones, use something like DCMT, so it's just the actual tip that's it's going to be like a fly cutter on the bottom surface, and then the edge of the cutter cutting the actual dovetail. But that went on a little bit longer than what I thought it was going to do. But I'll show the jig that I used to cut the gib. Right, this is the jig that I used to cut the gib strip. I've been on YouTube, seen these types of jigs a few times. There's Inheritance Machining and Tin Barner, two of them that spring to mind. So I made this. This is the jig that I made. It's just bolted down directly to the holes. There's no clamps or anything like that. and then you'll put your strip of brass or steel in there, and that's recessed, look, recessed in the middle. So when you clamp it down, it's only putting pressure on. Well, basically that stops and that puts the pressure on that toe gib. Now these, if you do decide to do it this way, they have to be indicated in both axes and also indicated that way. You need this. You need the vise trammed in, obviously. You need to, with this plate horizontal, you need to tram this in to make sure this jig is trammed in on the y-axis, and also, if you haven't got the work height like I haven't, to hook a bar, hook an angle block on the top. You can get them a square. You can get square blocks, can't you? And you've got the actual angle cut into the block, so you can use it to hook, or in a vise, set your part up so your part doesn't just slide straight down the angle block while you're trying to clamp it. Can't hook one on with that there. I can't sweep the top, so I had to use my indicator, the way that I've got my indicator set up anyway, to sweep the front of it, so I've got that angle right to then cut the gib. Otherwise, if you've got that and that and that not trimmed and indicated in right, you'll end up with an angled with a taper gib.